Welcome back to Engels Coach. This is Dave. When I bend 2-inch wagon bows, I begin with rough sawn 2-inch ash. I use ash mainly because of its strength and the fact it doesn't turn black in the steamer like oak does. When I rip slats off the board, it gives a vertical grain, and I like to cut them at about 3/4 of an inch so I can plane them down and end up with 5/8 inch thick when we're finished. I use an old saw. It's an old Wagon. It's a fairly heavy duty saw. As you can see here, it's powered by a flat belt off a 10-horse motor, and it just walks right through this 2-inch lumber. The saw I use is a Wagon saw, most likely built in the 20s. It's a Finnish saw. It's called a sliding table saw. It's a dual arbor saw. It can take two 16-inch saw blades, and as you rotate these, whichever saw comes up to the top is the one that receives the power. The top one, you can see I have a Diablo blade, is a 16 5/16 blade. When the saw is running, oftentimes both saw blades are turning, but the saw on the top is the one that's actually under power. The bottom one is actually just kind of floating there. A lot of my saws are 3-phase. This one is also a 3-phase saw. The miter fence on the top just pins right into the table, and you can see the degree index cast right into the table also. And instead of just sliding the miter fence, this is a sliding table saw, and the half of the saw table here slides instead of just the miter itself. So it allows to give a real accurate saw or a real accurate cut. The fence is easily adjustable on a slide, but you can tighten the center screw and then you go to the back screw, and it actually gives you a real fine adjustment. You can move it up just by fractions of an inch. Makes for a real nice accurate saw. Another feature about this table that it swivels, so you can actually do a coping cut. You run this angled across the blade and have a coping, make your coping molding. The fence on it is also adjustable. So you have that adjustment, which is handy at times. And so the whole mechanism also can slide back on the fence or on the table. It actually slide back to where you can cut a full 26 inches deep. Now beside the fence tilting, the table also tilts from 0 to 45 degrees. It's a real heavy cast iron table, and it's real difficult to move. But you can see here the whole table is adjustable. The blade doesn't adjust like the modern saws. So this is the saw that I use here in the shop. So after all the slats are ripped, go ahead and run them through the planer. I'll do a couple at a time, usually the first time to get them all down to a uniform thickness. Then as they're more uniform, I'll start to load up the planer and saw, or plane more of them at a time. After we've got them all down to the thickness we want, the 5/8, we'll turn them on edge and take them down to the width that we need. And these particular bows we're taking down to 2-inch. So this is the kind of the process of just getting the rough slats sawn out. So after the slats are all down to dimension, I take a router and we route off all the outside corners. This is where the canvas would come in contact. And rounding off the corners keeps the canvas from wearing through and ripping. So this bunch here, I've got probably, I think, about 40 bows I've got ripped out. We're going to turn these into sheep wagon bows. So just take the time to go through and route all the corners on the top edges. Then these are 14 2-inch long bows, so I'm going to go 7'1" and mark where the center is going to be, so I know just how to line them up when we go to the bender. So this is kind of the prep work before we actually start doing the bending on the bows themselves. This is the press that I built to bend bows on. It's built on a big I-beam. It's probably 8-9 feet tall. But the cables come up over top down to the back, and I have two 30-to-1 gear reduction motors, so there's a 900-to-1 reduction right there, up to a pulley that cuts that in half, which gives me an 1800-to-1 reduction. The pulley goes from there up over the top, the cables do, down to the front of this press, where they come to another set of pulleys which divide directions, and then the cables go down to each side of the metal banding that is attached here by these clamps that will thread the bows through. The steamer that I have here is 15 foot long. It's 10 inches square. It's a coal-fired boiler. Inside this outside tube, there's a tank inside which holds about 40 gallons of water. This whole thing is kind of a self-contained steamer. Since I do build pressure, I have a gauge on the top that I monitor pressure. You see now we've got steam starting to generate, so I'm going to load up our bows. I'm going to do 9 at a time. So I'm going to load the first 6. I have a rack built inside here that can suspend the bows inside the tank. So there's the first 6, and we're going to put our second 3. That's going to give us our 9 bows that we're going to bend here today. So once they're all in position, I'm going to close this door. It has a gasket on the inside, kind of seal it up. Now I don't like 100% seal. I do actually like some steam to blow by. It creates a wetter steam. And it takes about an hour to build pressure. Here we see I've got about a pound and a quarter pressure. And this is when I actually start my countdown. These bows are going to be in this steamer for the next hour and a half. It's 2 hours for every inch thick. And as it sits here and cooks, you can see it's going to drip and condense. And if I seal it up, it actually produces kind of a dry steam. So these are going to sit here for the next hour and a half and just cook. So now they've spent their time. I'm going to release a valve in the back that's going to put the excess steam and pressure down into the drain system, and kind of cautious releasing the door here. In the process of releasing, the pressure sometimes sucks the water from the boiler up into the tank, so I'm kind of letting it kind of funnel back into the boiler, and we're going to take our first 3. My round edge is going to go down, because that's going to be the outside of the bow. I'm going to thread it through the bracket on the end. Look for my pencil marks and find where the center is. Kind of line them up, stack them on top of each other, and get ready for the next 3. You can see they're plenty hot. There's a lot of steam coming out. They kind of sag a little bit. They aren't really wet as a wet noodle. You oftentimes hear that description. They're so wet that you can tie them in a knot. But they do have a soggy kind of a feel to them if they've taken on good moisture. So it's good to see that limpness to them. So now there's put our third set in, so we have 9, 3 wide, 3 deep. Now we're going to bring the form down. Now we got these where the center is. We're going to bring the form down and actually clamp the bows down to the table underneath. Hold these bows in place. Put just a light pressure on them to hold them so they don't move. Then out on the ends, we're going to make sure they're in line. We're going to bring the metal band up to the back side. I've got a block and a C-clamp that's going to help hold the metal band in place and hold the bows in their proper place. And we've got to do this on both sides. We're going to bring them all down. We're going to fasten our clamp to the band and our board and our clamp on this side also. Now once we're clamped in place, we can go ahead and turn it on and start to bring it up. Now because it's 60 or 1800 to 1 reduction, it's a fairly slow process, but you can see starting to bring it up, how slowly it moves, but it actually is nice because all wood bending is compression. That's the purpose of the metal band outside. You cannot stretch wood, but you can compress wood, so that metal banding helps the outside of the wood from stretching, which would cause it to break. So I'm using the half round wood form as a gauge to see that it's coming up in its correct position. I don't want it to come up as a corkscrew. We want them to lay parallel to each other as they come up. You can see that's just slowly pulling them up around the form. As the wood makes contact, then it just keeps coming on around. Cables are pulling up over the top, down to the pulley in the back, and down to the motors. Now sometimes through here I'll stop and make kind of a quick adjustment if some of the bows aren't exactly in place. I'll take a wood block and push the bows that need to be moved, adjusted. This time I had a couple on the back side that were not really in the right place. I'm going to just tap them into place while they're still soft and go ahead and finish bringing them up around the form. So constantly watching the form, constantly adjusting in and out, making sure they're uniform around the form. Now we're getting up close to the top. I'm going to start watching the ends as they come to the end of the form and make sure we stop when the legs are pointed straight up. And right about here is where we want to stop. So I'm going to check across the face of them, make sure they are parallel so that they are straight. And this is kind of how we have our bows bent. I'm going to double check that there's contact of the wood clear around the form. If there were any spaces, I'd take a pipe clamp and pull them up into place while they're still soft. But this is how they look when they're freshly bent. Now they're going to stay on this form for a while, and while they're cooling off, I'm going to go ahead and load the steamer with the next batch. And in the next hour and a half to 2 that these are steaming, the bows here are going to cool off on the form. After this hour and a half or 2, I'm going to take a nice light nylon cord and going to tie across the ends of the bows, because I need to release the pressure off of the cable and get these bows off of the form so that the form is ready for the next set of bows. Now these bows aren't dry in this 2 hours, but the heat has come out. The moisture hasn't come out, but the heat has come out. So when the heat comes out, it allows the fibers in the wood to reset, to firm up, and to actually start to hold their shape. Because these are only 5/8 of an inch thick, they do hold their shape fairly well. But now I can take the form up, lift it up, take it off of the bows. They don't need to be clamped anymore. And I'm going to release my brackets on the end so that I can slide these bows out of the metal strap and off of the form. Now the wood is still kind of soft. It's only a couple hours out of the steamer, so I have to be kind of a little gentle getting them out. Work them out from underneath the form. About to get them off here. Once I get them off, I'm going to pick them up here. I'm going to turn them around to where they're actually right side up to how they would fit onto the sheep wagon when they get built. Oftentimes I'll take and kind of tap them on the floor. It allows the ends to come down to where they're all the same. Then I'm going to take a couple of brackets that I have made. I'm going to slide them over the top of these bows that actually hold the bows in place. That'll allow me time to take the nylon cord off. And in these brackets is where they'll sit and actually start to dry. It'll take these about 24 hours to really cool down and be fairly safe in their shape. They're going to be kind of gentle for a little while. But I put 6 per bundle. That's generally the most common number of bows that go on a sheep wagon. The next bundle I bend will be 9 also, so I have the separate 3. So I'll have a separate third on the next set, combine those two, and then I'll have another bundle of 6. So that's kind of the process of steam bending sheep wagon bows. Here's a picture of them finished. There's 6 set here that's going to the Idaho Sheep Camp Company in Boise, Idaho, getting ready for the truck. Anyway, we appreciate you watching, and we'll see you next time.